Geometry, Unit 7, Section 5, the angle bisector theorem. There is no video in this series for Section 4, so if you're looking for that, you're not going to find it. But for Section 5, we have the angle bisector theorem, and you're in the right place. And the angle bisector theorem says this, that the angle bisector, let me read it properly, the bisector of an angle of a triangle splits the opposite side into segments that have the same ratios as the adjacent side. And so what that means is here we have triangle ABC, this big triangle here, and what we see is that AD here is the angle bisector for angle A. So we would say that AD bisects angle A. And what that does is, so AD is the angle bisector. This AD is the angle bisector. And what AD is doing is it's not only bisecting angle A, it's not only cutting A in half, where if it were 80, now it's 40, 40. It's not only bisecting angle A, it is not bisecting this, but it is splitting this side opposite angle A, the side CB. It is not bisecting it, but it is splitting it into two segments that have a proportionate length to these segments. And so what that means is that, 6 to x is going to have the same ratio as 8 to 12. So it splits the opposite side, CB, into segments that have the same ratio as the adjacent sides of angle A's ratio. So what we can say is that 6 over x, 6 over, well, let me not box one, let me do both circles. 6 over x is proportionate to 8 over 12. And I want, if 6 is on top, then the left side of the angle bisector, the adjacent side, 8, that's going to be on top. And the right side, x is on the bottom, that means 12 is going to be on the bottom. And so we can solve this proportion here. We can cross multiply. And is my timer going? Yeah. Just making sure this is recording and I'm not just talking to myself. So yes, so now we can cross multiply here. We had 8 times x, 8x, 6 times 12. That would be 36, 12, so 72, and we could divide by this, and we get x equals 9. And then, of course, we want to write that means that dB equals 9. And so that is our answer there. And so this is basically just another way to get proportions and things like that. Do you think these triangles are similar to each other? Is it true that ACD, triangle ACD is similar? That's an ugly similar way. Let me be a little bit neater here. ACD is similar to triangle. That's not much better. ABD are these similar triangles? Well, we know these angles are congruent for sure. But that's really the only angle congruence we definitely know. We don't know if these angles are congruent or if these angles are congruent. We know that these sides are proportionate. 8 to 12, 6 to x, and 8 to 12, that's a ratio of 2 to 3. So 8 to 12 is a ratio of 2 to 3. 6 to x, that's a ratio of 2 to 3. But the reason why this is false is because whatever this length is, AD, it's not going to be, AD to itself is not a ratio of 2 to 3. So, these sides are proportionate and these sides are proportionate of a 2 to 3, 2 to 3, but this reflexive side would be a ratio of 1 to 1, and so not all 3 sides are proportionate, only these 2 sides and these 2 sides. So this does not create similar triangles, and it's kind of an odd place that we're doing this in a chapter called similarity. It's just because it does create a proportion, and we see a lot of proportions in similar triangles, but I don't want you to be confused by that we are not dealing with similarity here, but we are dealing with proportions. So let's look at one more example here. So this one wants us to construct the angle bisector of S. And you're told that QR, this whole piece, is 21. I want to find what it's going to be segmented into. So I'll take my compass and do the angle bisector construction, which is one of our easier constructions, really. We just draw an arc, So that hits the angle twice, and then from those spots, we draw another arc, and it's good to extend this a little bit. It's a little bit neater when you do that. And I'll also go from the other spot my angle crossed. And then where these arcs cross, that connected to angle S is the angle bisector. So that's angle S bisected. All right, so that's good, but how do we now find the lengths of, this piece and this piece? I know that they're proportionate. They're proportionate to, 16 over 12. 16 over 12 is proportionate to, A over B, but I don't want two variables. But I do know this whole thing's 21, so what I could do is I could maybe make one of them x and then create another expression over here. Again, I don't want another variable, but I could say that this would be the whole thing minus this piece x over here. So that would be x over 21 minus x. And that's what I can use as my proportions cross multiply here. And so I'll cross multiply here, I'll get 12x. Cross multiply here, I'm going to have to distribute a little bit. I don't have my calculator up here, I have one on the side. But 16 times 21 is 336 minus 16x. Don't forget to distribute when you're multiplying by a polynomial. Okay, and so I could add 16 and get 28x equals 336. Divide by 28, divide by 28, and I get x equals 336 divided by 28 is 12. And the one thing you have to be careful here is, what if I had made this side x? Then wouldn't this one be 21 minus x? It would. So when you're doing this question and solving for x, the problem doesn't know which side you made x and which one you made the whole thing minus x. So when you get x equals 12, you have to figure out what that other piece is. What's 21 minus x now? 21 minus x would be 21 minus 12. That would be 9. And so you kind of have to decide which side is 9, which side is 12. And the smaller number is going to be on the side with the smaller adjacent side. You see, I have 16 and 12 over here. 12 is the smaller. That means that this is going to be the smaller one, 12. Since 16 is larger, that means this is going to be the larger one, 12, between these two. So whichever one you make x and the other one the whole minus x, just know that it might not be the right one. So just make sure that, if you're looking for the smaller piece, you choose the smaller of the two numbers. Or if you're looking for the larger, typically they want both here, so you'll need both answers. And that's basically it for the angle bisector theorem. Like I said, it just creates a proportion of the side that's split into two segments. That ratio is the same ratio as the adjacent sides, but they are not similar triangles. I mean, look at these two triangles. They do not look like they are scale images of each other at all. So no similarity there, just proportions. That's it. See you.